Hello again. Before I start, small disclaimer: it's my first presentation in English language, so I start to do it as smooth as I can. My talk was about what it takes to train a Gen AI model from scratch. Two words about me. My name is Narek Tatevosyan. I'm product director at Nebius AI. At Nebius AI, we built a cloud for AI, for teams who train models, who fine-tune models, who run the models for the production. Before working in Nebius AI, I built multiple types of clouds, and actually, like machine learning was my hobby through like tens of the years. So I'm really happy that finally my favorite hobby and my work combined together. So before I start, I want to understand how deep should I go. Actually, I have only 20 minutes, so I will ask a small question to you guys. Is there anyone who actually trained a model or fine-tuned a model? Please raise your hand. Oh, it's good that we have a balanced, you are balanced auditory. Yes, so I will not go deep in some moments. I will go a little bit high level, so to explain all the problems. So what I'm going to talk about? I'm going to talk about a path that modern research teams, research startups are going when they want to train some model from the idea to production. This training process is much more complicated than it was before, I would say, in conventional traditional AI. I will tell you in details about like data preparation, experiments for pre-training, and alignment. My experience is based on a view of a service provider working with our internal LLM team and our external customers who train LLMs, text-to-image, text-to-video, multimodal models. I will go in my talk taking an example of how to train an LLM, but I would say that multimodal is even more complex than LLM, so this is like a good basic block that can be reused. So let's start with data preparation. So why do you need to prepare a data set? I think it's obvious. You have to create a good data set to train your model. In case of creating an LLM, it's actually taking a lot of sources from the internet, unstructured sources from the internet, run them through a complex pipeline, because in the end you have to get these tokens. Tokens is a language that LLMs speak, even if you speak when it's on production, and when you train a model, models also work with tokens. To do that, you need to filter, deduplicate, structure this data. The main thing is that to do that, you have to use a lot of CPU cores or GPUs in some cases. And your data sets are big. It's hundreds of terabytes for LLMs. If you go to the multimodal, it's petabytes. If it's images, it's petabytes. If it's videos, it's tens of petabytes. What are the challenges in this stage? I think, yes, as I told, it's obvious that quality of your data set is actually key to your success. But to reach to your success, you have to put your data through the complex pipeline, which will consume a lot of time, consume a lot of resources. And size of data sets are growing. Like a year ago, open source models were trained with 2 trillion tokens. It's about 20 million books. This year, like good example is Llama 3. Data sets already consist 15 trillion tokens. It's 150 million books that you have to prepare to train a model. It's a lot. You are lucky a little bit that if you're training a model using English language, but if you go to another language, you have to get more data, just raw data to train them. How to deal with it? So as I told you, as you see before, creating a data set is a complex pipeline which consumes a lot of resources. So understanding how your tokens are produced to train a model is actually super important, because this is part of your success, part of your IP. So there is a good concept, it's called data lineage, is a concept that you implement some amount of techniques to understand the way how your token is produced from like open source information through the whole pipeline. To achieve that, you have to version everything, version your datasets, version your pipelines. Also important thing to understand that, as I told you, that datasets are huge. You can't explore your data on your laptop. You need to explore your data using special tooling that can work on a scale. In our platform, we create tools to help you with it. We create our own tools, like there is example of Tract.ai. It's our own tool created to prepare datasets and to run distributed training. Also, there is a lot of open source is going on. Spark, one of the most important, most popular tools to prepare datasets. And also, I see that Slurm is becoming a tool to prepare datasets. For example, a month ago, Hugging Face released Fine Web dataset. It's 50 trillion dataset. And they released a pipeline which created this dataset, and this pipeline used Slurm to prepare a data. So like Slurm is becoming one of the tools to do everything. Also, all of these tools, even Spark, Slurm, Tract.ai, is runtimes to prepare your dataset, but you need to orchestrate it. You need to create a pipeline. So you also need a tool to orchestrate pipelines. Airflow is traditional one. It came from the data engineering. And Prefect is some emerging tool that is also becoming more popular for ML tasks. Let's go through the 3 stages of training, I would say. Why it's so complex, let's talk about that. So, experiments. Why it's important to run experiments before you go to the pre-training. It's important because you can't just go to the internet and read how to train a big model. So it's like IP of a lot of companies. They do not share how to do it, but a lot of information is written in research papers, which they produce, or in some blogs. So there are a lot of ideas that you can use to create your own model. You have to test and develop their models, but it's not enough, because your ideas has to scale when you go to the multi-node training. Sometimes your ideas can work on smaller scale, but if you add scale, you will just lose your GPU time, and have some problems. Also, I told you before that like experiment is a place where you can validate your data set and way that you created your data set, whether it's good or not for your cases. So what can I can recommend here? Yeah, so again, like model data set and like ideas, like a code that creates your model is actually important part of your IP. So it needs to be tracked, it needs to be versioned, because some ideas even can be reused in a year or something. I would say that there is a popular tool, MLflow, that's used to check experiments. Some of our users use it. Also, I see that Weights and Biases being like the most maybe popular commercial company who helping to run experiments also is one of the best tools to actually to track the experiments. Also, this was a little bit maybe obvious that everything should be tracked, but also there is another important thing that I told you, that there are a lot of ideas that you have to test. You have to test them in 2 ways, whether they actually work and whether they scale. So this is like 2 dimensions of testing your ideas and running experiments. How to deal with it? Good practice is to have experiments at different scales. So start with a smaller scale, check whether your ideas is working, and then go to multi-nodes and add scale. This is on a slide. There is an example of 3 scales of experiments, which consumes multiple types of compute, which has multiple sizes of data sets. Obviously, in small experiments, you don't need large data sets. You can use smaller data sets. But if you add more compute, add more data, and check whether it works. It will help you for the most cases to run pre-training. But it wouldn't help to solve all the problems. Let's go further. So let's talk about pre-training. So actually, pre-training is a phase when you create your foundational model, where you put data to your model when it learns about the world. Yeah. What is important about pre-training is actually the most complex. There are couple complex parts, but one of the complex parts is amount of compute that you have to get. This is an example of one of the models which were trained in our platform. Important thing that I want to tell that on the experiment phase, on the alignment phase, you don't need so much compute. You can use much less. You will spend less time to run one iteration of training. But on pre-training phase, it's 1,000 instead of hundreds GPUs. It's trillions tokens instead of billions tokens. It's months for one iteration instead of days. So it's much more. You will spend on this phase much more, and mistakes that you made will cost you much more than on previous stages. So you have to prepare for it to understand how can you deal with it. So first thing is important is that you have to get a big cluster. What is the problems of big cluster is that it's not that easy to get it. It's not that easy to get it from one place, and eventually you will become multi-cloud, multi-cluster. This is what we see with all our customers, and it will lead that maybe you will start experiments in one place, run training in another place. If you're a cloud company, if you're a cloud native company who are used to cloud native experience, you will see that not all the clusters are built by given to you as a cloud. Some of them are just physical clusters, and you will get IP addresses with SSH access that you have to work. Some of the companies are clouds, but also it's not enough, because we see that any change in cluster physical architecture can lead to some new problems on your pre-training stage. You will work, you can run experiments in one cloud, come to another, you will just get some new challenges because infrastructure has changed. If you are not prepared for that, you will lose your time using this big cluster. But this time is super valuable for you. It's a lot of money that you spend to run. How to deal with it? So test before you go to production. It's like an obvious answer. If you talk to your provider, ask some time to onboard, to run some tests before you pay him the whole money. What test suits can help you? We see that there is a Nickel test suite. Nickel is a library which NVIDIA used to, which NVIDIA leveraged to run training. They have test suites and test, which is like, it's called Nickel all reduced test. It helps you to validate that your InfiniBand is working in the good speed. So it's something that a lot of people use to benchmark multiple clusters. But it's not enough because you need to understand whether your cluster is stable or not. You need to run some training on some longer period than just checking the speed of your cluster. So it's a good idea to run a good full-blown pre-training before you go to production. If you don't have your model ready yet, you can use ML Commons. ML Commons is a non-profit organization who actually creates tests to validate all possible ML workloads in all possible cases. And they have GPT-3 model and Stable Diffusion model that can be used to check stability of a cluster. And talk to your provider, take your time to test before you go to production and understand whether they have experience understanding their customer or they're just giving you some hardware to listen, don't understand anything about your problems. So in our platform, we run all the tests. We run Nickel tests. We run ML Commons before we give compute to our customers. And we have, as I mentioned before, we have our internal LLM team. They run the full-blown training of our internal LLM before we give it to our customer. So in our case, you will get compute much more ready to your needs. Another case is challenge is checkpoints. Actually, problem is not about checkpoints. Problem is more complex. GPUs fails a lot. They fail more than usual CPUs, usual servers. Reasons can be multiple. I think obvious one is that the GPUs consume much more electricity and not so ready to eat sometimes. Sometimes maybe people are in rush to provide you better GPUs, but they fail. And the problem is, for example, you run pre-training with 2,000 GPUs, and if one GPU fails, the whole process is stopped. You lost all your progress. How to deal with it? To deal with it, there is a technique. It's called checkpoint. It's very simple technique, actually. Like if you play some game, you can save state of your game. If you play a video game, you can save your state and start from some moment. Checkpoint is the same, but for the training. You train your model, you save state of your training, and if something goes wrong, you restart from this state. But in games, saving usually is like super easy. You just push save button. If you train a model and do checkpoints not correctly, you can slow down your training process. And if you slow down your training process on this huge cluster, you will lose money, lose your time, because time is super valuable. How to deal with it? First thing is that to understand how checkpoints work. So when you write checkpoints, when you save your state, your training is stopped. You have to minimize time of this writing. The most popular technique is to use async checkpoints. This technique is simple. This technique writes checkpoints to RAM of one of the hosts, of multiple hosts, and training continues. And when training continues, checkpoint is written to persistent storage. So you just spend time to put checkpoints to RAM of one of multiple hosts. Second thing is then, if you restart your checkpoints, all the host has to read these checkpoints to restart training. So you have to parallelize this reading, because sometimes one of the hosts can be bottleneck. So there is a technique called sharded checkpoints that can help you with. So these techniques are implemented and becoming implemented in modern libraries, like JAX Orbox has support for it. PyTorch Lightning has support for async checkpoints. So like read documentation carefully, read best practices, how to use these frameworks to not to waste your time. Also, I told you that we see it in real life that you made a lot of experiments on the scale. But if you train your model, your training can, like for example, you train your model on this big scale, and for example, we see situations when it's already a week of training has passed, and something goes wrong with the training. Like some bugs appeared after some moments. You couldn't find them on experiment cases, but it means that you have to stop your training and find some bugs in your architecture and restart your training from good particular moment where like everything was working. To do that, also it's important not to write checkpoint only for high availability, but important to run them to restart from correct moment. So to do that, you also have to track them, you also have to version them to understand what is correct place to restart. In our platform, we have like checkpoints usually require fast storage and fast shard storage between hosts. And we see that if model size are growing, these checkpoint size are growing, and requirements to the storages are growing. So we continuously increase the speed of our shared storage to cope with these needs. Also, if you use StructAI, they have native support for checkpoints. Right now, we built POC for JAX. We're building a solution for Lightning, for PyTorch Lightning, and then, like, if you use Tractor, you can track and version checkpoint from the box. Okay, let's go further. So let's talk about alignment and why it's alignment and not fine-tuning. Actually, like fine-tuning is one of the way to take your foundational model and create model ready for real-life usage. Fine-tuning is one of the ways to do that. It's like using labeled data to do that. Reinforcement learning with human feedback is another way. LoRa is also another way which help you on the inference cases. There are also like new techniques emerging, coming. This area is much more emerging right now, I would say, in practitioners' market. Thank you to Mistral, thank you to Meta, who create open source models that can be reused for everyone else who don't have access to such big clusters. So what is important about alignment? Actually, alignment is again about experiments. All the techniques that I told you before can be reused and should be reused to track progress of your experiments, version results of experiments. The tools are actually the same. Important thing that alignment is not so compute intensive as pre-training. For example, to align Llama 7TB, one host of H100 with 8 GPUs is enough. But if you want to go like 300 billions, one host wouldn't be enough. You also have to go to the multi-node training. So in some cases, even in alignment, phase, multi-node training is important. Also important thing that, we was discussing with our internal team, that a lot of methods and techniques of alignment that you used with one model can be transferred with another model. Easily transferred. It's not like copy-pasting, it's writing some code and rerunning training. Nevertheless, it's important to mention because you can start aligning one model, and when new top model appears in the open source, you can reuse all the techniques to align it. So again, tooling, processes, problems in alignment phase are much more the same as experiment and pre-training, but with a much more smaller scale. So to conclude, to run training, you need a set of tools. Tools are changing. We see that open source is emerging in some interesting place. We see that like Slurm is becoming one of the platforms to run pre-training cases, and it wasn't like designed for that, but as we see that it's really helping people to run their problems. So a lot of tools are emerging. Some of them we see that becoming a standard like Slurm. Some of them are in emerging phase. So in our platform, you can use NVIDIA hardware, which is tailored for ML workloads. You can consume it as a cloud, not as a bare metal. So it's like friendly UI with Terraform provider, API, everything. You can get on-demand compute, reserve compute if you want. You can use platform services that we offer, like Kubernetes, Slurm, Tract AI. You can use a lot of third-party solutions, install them by yourself, or use our marketplace. So we are creating a cloud for these problems, not only for training, but this presentation is about training. So if you're interested in some details, I invite you to come to our booth to talk. We are sitting booth 105, where we can have a talk. Also, if you're interested to test our platform, you can just come to our website, Nebius AI, and just sign in and get the H100s in like 5 minutes. So thank you. I'm open to your questions.
Any questions?
Yes.
You go with. Yeah.
Hi, and thank you. It's truly insightful. I was just wondering, building an LLM from scratch is really expensive, and often, because of the way it's evolving so fast, it's not usually as good as... I work at Bloomberg, and we've got BBGPT, and it was built from scratch. It cost over, like, in the trillions, and it didn't sort of keep up with, say, ChatGPT, because you need to keep evolving. So I was just wondering, what sort of use cases do you see in actually building it from scratch, or is it better to leverage open source existing ones and use things like RAG to sort of leverage
Good question,
more?
yes. So there are cases, in cases when GPT is not enough. For example, new languages. So sometimes, like, we see cases when there are providers who have models who understand like 12 Indian languages or like some dialects of Arab languages. So this is one of the cases where it's going to emerge. Another case is actually, like you mentioned, yes, ChatGPT, yes, OpenAI, but there are also like multimodal cases that are emerging. Yes, so in such cases, you don't have much offerings in the market, I would say. You can use Midjourney sometimes. We see that OpenAI is going to Sora, but we see that right now a lot of companies are going to the multimodality. So this could be also a case when you need to train it from the scratch. But for LLMs, to be honest, if you use like English language particularly, yes, it's like start from OpenAI, then think about fine-tuning or actually, this is what people in real life do, yes, if you are not like a team of scientists, I would say.
Thank you very much. Okay, so we have one last question.
Just very quickly with where you see the future where we're talking about peak data and other such constraints to go towards the next level, whether you see anything in your horizon that might help resolve some of those as well as the compute.
Can you repeat the first part of the question?
Idea that we're at a constraint with things like the amount of data available to be able to train to that next level of generation. I was wondering if you see any sort of solutions around that.
We see that as we talk with like enterprise customers, and we realized that 80% of data is still hidden under the firewalls. So it could lead to like multiple cases. It can actually lead for like this is like one part of equation. Another part of equation that from some moment but these customers using fine tuning right now, yes, alignment, multiple techniques for that, REC for some cases. But like data is growing, and in some cases there is situations when like even enterprise with a lot of data is thinking about to pre-train something because they don't want to share their data out of it. So this is where industry can go. But right now, I would say it's too early because you can get a lot of success using like RAG or fine tuning, using your own proprietary data. But if there are going to be more success, these companies going to transfer to pre-training, but it's going to take, I think, years maybe.